Here we are looking at our Unit 6 study guide. Now, for the sake of this video, we're going to stick with just the evens. But yeah, going over, how to graph a function, how to factor a function, quadratic formula, how to solve these things. So pretty much everything from 6.1 to 6.6. And to kick it off, we're going to look at what is required of us for the graphing components. So as we kind of look at what we're trying to find, we have our vertex, our axis of symmetry, the y-intercept, the other point that we saw with that reflection using your axis of symmetry, and then finally the domain and range. So as we look at number 2, this question comes straight from our 6.1 number 2 set of notes. So if you need to reference that table, feel free, it's right there. So what we're going to go ahead and do is we notice that it's in standard form. We've got y equals ax squared plus bx plus c. And recall, this is where we identify our a, b, and c. And then to find the vertex, item 1 is saying we need to find the vertex. It is x equals the opposite of b over 2 times a. And so now, having identified what those are, we're going to go ahead and dump those items in. And when we do that, we end up with negative of b happens to be a negative number. So notice how, recall that they're their own negatives, over 2 times our a value. In this case, a is 1/2. Simplifying this up, we end up with the opposite of -4 really becomes +4 on top. So we have 4 over. And then 2 times 1/2 on the bottom is just 1. And so our x value comes out to be 4 divided by 1 is just 4. Okay. Now that we have found the x value, we need to go ahead and find the y value. So what we're going to do is then dump in that x value that we just found into our original equation. So we have 1/2 times 4 squared minus 4 times 4, and then finally plus 4. Next, we're going to go ahead and do our little bit of GEMDAS. So 1/2, 4 squared is 16, so times 16. And then minus 4 times 4 would be minus 16 plus 4. Now we have half of 16, which is 8, minus 16 plus 4. And then finally, combining like terms, we end up with 8 minus 16 is -8 plus 4 would be -4. So our vertex, we have located it at 4, -4. Okay, so that again was our part 1. And what we'll go ahead and do is graph that at 4, -4. Boom, there's our vertex. Next, we're going to go ahead and find out the axis of symmetry. Now, if you're like, man, that was a lot of work just to find the vertex, well, that was the hardest thing that you pretty much have to do for this question. The rest is you're going to find and recall that it's pretty quick. So our axis of symmetry, the second item, axis of symmetry, is the x value from our vertex. So literally just x equals 4. And yes, recall that we do need to have that x equals because that's what creates that mirror. So if you just put the number 4, that would be incorrect because that is an integer. We need x equals that. So now we go ahead and graph that. Here is our mirror. X equals 4, that axis of symmetry. Now the y-intercept. When we go and find that, we have our original function. Well, if we're trying to figure out where is it crossing this y-axis, the x value every single time is going to be 0. It's going to be 0 some number. So for your y-intercept, we're always going to dump in 0 in for x, and then it's going to be some value. Well, when it's in standard form, if you were to dump 0 in here, we would have y equals 1/2 times 0 squared minus 4 times 0 plus 4. Well, any 0 raised to anything is still 0 times 1/2. This is essentially going to be 0. -4 times 0 is going to be 0. And then finally, plus 4. 0 plus 0 plus 4 is just 4. And so recall when we learned in standard form, it's literally 0, comma, your C value, that last number. And so now we can go ahead and plot that. Now, unfortunately, most of the time you can go ahead, but unfortunately, this would run off of our graph. And that's then where these other points come in to help us out in creating our parabola. So next, we're going to be trying to figure out what is the other point that's close to the vertex. And again, you want to choose something that is close to your vertex, this guy, that you haven't already used. Now, a value would maybe be only 1 away from there, like we might use 3 or we might use 5. However, notice that we have a fraction here. And if you use 3 and 5, that's fine. You can use it. You'll just end up with fractions. To make our lives a little bit easier, I'm going to go ahead and choose an even number. So like 2 or 6, because then when it interacts with that 1/2, we get clean stuff in the end. Remember, with the other point, you get to really choose what that is. So I'm going to go ahead and choose. We'll go with 2 because it's small. Actually, no, we'll use 6 because there's a lot of other 2s going on the screen. So we'll use 6. So I'm going to choose x to be 6. And all I do, again, this is for our other point. So this is for number 4. Here's 3. I'm going to choose x to be 6 and then pretty much dump that item in. So we have y equals 1/2 times 6 squared minus 4 times 6 plus 4. And now we pretty much just follow GEMDAS. So we have 6 squared is 36. -4 times 6 is -24. 1/2 of 36 gives us 18. And then 18 plus -24 would be -6. So we have -6 plus 4, which is -2. So for our other point, recall, we let x be 6, and then we got -2 as a result. And so when we go to graph it, we've got 6, -2 located right there. Now, for the reflection, going with that, our reflection point. Well, noticing this is where our axis of symmetry comes in. If we are 2 units on that left side of the mirror, then we'd have to go 2 units. I'm sorry, since we were 2 units to the right of the mirror, we'd have to go 2 units to the left of the mirror, place our dot there. And wherever that's located, that is our reflection point. So 2, -2 is where we find it. Finally, we have our domain. And range part. To kind of help us out with that, we're going to go ahead and create our parabola. So we're going to connect these now. Imagine your U is doing something like this. So we see our U going up. And again, we have that curve. So there's our parabola. Now comes the domain and range. So this is number 5, domain and range. For our domain, recall that domain controls the x's and range controls the y's. For domain for parabolas, they generally go outward forever in this direction and outward forever in this direction. So generally speaking, they are from -infinity to +infinity. And since we can't ever hold infinity in our hand, they always have that parentheses. Okay. Now for the range, these are the y's. We read that from bottom to top. Well, the smallest y value is coming from the vertex. It's not going any lower than that. And that y value is -4. So we're going to start off at -4. And since we can actually be that value, like we can hold that because that's our minimum value there, we would then have a bracket. And then noticing the y values, they go up forever and ever and ever. There is no top that it'll ever reach. And so because of that, it goes to positive infinity. And there's our domain and range. Now, a couple things with this. We notice that we have our a value being 1/2. Recall, if it's positive, it's going to go upwards, creating that minimum, which we see. And because it's also 1/2, it does widen out like that. So your standard, parent function x squared, 1x squared is like this, but because it's 1/2, it widens outward. Go ahead, feel free to pause the video if you have any questions, though. All right, next up, we're going to look at 4. This is vertex form. So for vertex form, recall that this is that form where it's y equals some a value times x minus h quantity squared, and then plus k on the outside. Now, when we go to find the vertex, so for number 1, our vertex, recall that it is just the opposite of this value inside. So because it's +4, it would be -4. And then for our k value, we take this guy just as he is. So since it says +2, we have a +2 there. You don't need the positive, but it's just 2. And right there, we already have our vertex. So there's no x equals opposite of b over 2 times a, none of that. You don't need to do that. It's already given to you, essentially. But remember, it's the opposite of the number in the parenthesis, and then you take the number on the outside just as it is. And again, it's this k value on the right side of it. Now we'll go ahead and plot that. We have -4, +2, located right here. We see that our a value is -2, so this is going to reflect about the x-axis. So it's going to be, going downward, and it's going to create that max as a result because a is negative. So it's going to go down. We're going to see a u going down and creating that max. So now we're going to go ahead and find the axis of symmetry. So axis of symmetry. And it's pretty much just like before with number 2. It is x equals the x value from our vertex. So whatever this number is, in this case, we see it as -4. And recall, that is your mirror going on. So it is that mirror, x equals -4 in this case. Now moving on to 3 already. For 3, this is where we have to find the y-intercept. And every single time we're finding in all of math, when we're trying to find out what is our y-intercept, well, x has to be 0. No way around it. We're trying to figure out where is it crossing this y-axis. Well, the x value, you're not moving left or right any. That's why it's this value, 0 specifically there. So when we dump 0 in, this is where you do actually have to kind of do the math, like you have to dump it in. You have -2 times, we're dumping 0 in, +4 squared, +2. And then we just simply do our GEMDAS though. So we have y equals -2 times 0 plus 4 is 4 squared, +2. And then 4 squared is 16, +2. And then we end up with -32 +2 or -30. So we dumped 0 in for our y-intercept, and we got -30 as a result. Now, that being such a large number, we're not going to have the opportunity to graph that one, okay? But we at least found it. Now, what we're going to go ahead and do is find out what is another point. And so, you probably just want to stick with something close to your vertex. And there are other ways too that you can do it, but I kind of like teaching where you have some other coordinate. Now there are other ways though, but we're going to stick with this one. So we have y equals, I'm going to say, remember, you want to choose something close to your vertex. Okay. So like maybe just one away from that. We don't have any fractions that we have to worry about in terms of our function. So I'm going to go ahead and just choose a value that's one away from that, like -3. So we have, I'm going to let x, you could choose -5, you could choose -6 if you want, but I'm going to let x be equal to -3. So again, it's from my other point. And so when we do that, we're going to dump in 0 in there. I'm sorry, we're dumping in -3 in there. We have -3 plus 4 squared, and then plus 2. So wherever there was that x, we dumped that value in. And now we just clean it up. So we have y equals -2. -3 plus 4 is is regular 1 squared plus 2. And so we have y coming out to be equal to -2. 1 squared is just 1. And then -2 times 1 is -2. And so we get 0 as a result. So recall, we let x be -3, and we got 0 as a result. So that is our other point. So -3, 0, boom, there he is. And notice we're 1 to the right of the mirror. For the reflection part, then we would have to go 1 to the left of the mirror. We place our dot there, and we notice that that is at -5, 0. So -5, 0. Again, that is really the whole purpose of our axis of symmetry, is to help us mirror items. So we'll go ahead and clean up this part. And now we can go ahead and create our U. So we should see a U. Notice how it's going kind of steeper down. It's kind of a thinner U than our last one was. That's because that a value -2, that especially 2, is making it what we call vertically stretch. It's getting thinner there. Now, because it was negative, we see our U going downward, creating that maximum that we've talked about. Okay. Finally, for domain and range, for our domain and range, domains are always just the x's, and for our parabolas, they pretty much go outward forever in that negative direction and outward forever in this positive direction. So domain, again, is -infinity to positive infinity. Can't ever hold those in your hand, so parentheses. Range, recall, again, those are the y's from bottom to top. And so this parabola will go downward forever. And because of that, the bottom will be -infinity, but you can't hold that in your hand, so parenthesis. And then as you move upward on the graph, as you kind of go to your top point that it'll ever reach, well, it maxes out right here at your vertex. So then that y value is 2. So it's going to go downward forever. And then the highest it'll ever get is 2. But because that is part of our vertex and we can be that, we have a bracket on him. Go ahead, feel free to pause the video if you have any questions. All right, next up, we're going to shift away from graphing and now focus on factoring. And so this is where we pretty much go through each of our sections and kind of discuss, how do you appropriately do all of 6.3. So these questions are coming from your 6.3. This one specifically is coming from 6.31. So what is our greatest common factor? Now, as we look at this, we can see that they're all evenly divisible by 5. So we're going to pull a 5 out, we know. And they also share an A. They all share an A. Now, the most that you can pull out of there is just one of them, because this guy only has 1 to give. So we can pull out a 5A in total. Now, when we do that, if we divide 35 by 5, we would have 7. And then because we pulled out an A, now he has only 2 left over. And recall, it's kind of our properties with exponents. Negative 10 divided by 5 would be negative 2. And then we pulled one of the A's out, and he had 2 to give. So he's got 1 left over. And then finally, positive 25 divided by 5 would be positive 5. And we already pulled the A out of him. And so then that would be our GCF. So this is our final answer. Now, normally you would try and break him down further, but for this one, we cannot do it. So that would be it. And that's really the point of this question, is just kind of going over factoring with the greatest common factor. All right, for our next one, this is 6.3, number 2. So if you need to reference this section, go for it. This is factoring when our A value is 1. Okay. So there's a couple different ways that we're going to do it. I'm going to show you both. Both of them are really good. So we're going to do our normal X method, where we've got our A times C. So A times C is 1 times 27, which is 27. And then our B value is 12. Now recall, this is where we need to make our list for 27. So we're thinking of all the things that multiply 27. We got 1, 27. We've got 3 and 9. And then that's pretty much it. Now, which of these pair in any possible combination give us 12? Like add up, maybe one of them's negative, maybe they're both positive. Well, it's going to be 3 and 9. 3 and 9 can give us 12. 1 and 27 can't do that. So it's 3 and 9. And so we have 3 and 9, and they would both have to be positive for that to happen. So now what we're going to go ahead and do is split that middle term. So we have 3A and 9A, and both of them are positive. And then recall the other items they just dropped out. Now we're going to go ahead and break it up down the middle. Now looking at this first half, it looks like we can pull out a GCF of 1A. They both share that. And when we pull out the 1A, we're left then with 1A plus 3. Because we've removed the A from both of them. This guy had 2 to give, he only had the 1 to give. When we look at the second part, our greatest common factor between these, well, we can pull a positive 3 out. We can't do A because this guy doesn't have 1 to give. And so when we divide both items by 3, factoring that 3 out, we get 3A. Oh, no, I'm sorry. We can pull out a 9. My apologies, guys. Our greatest common factor would be 9, because this is divisible by 9. So we have 9. And then when we divide both items by 9, we end up with 1A and then plus 3. 27 divided by 9, we get our 3. Now, these items match, and when we're factoring, that should happen. So imagine then you pull out that greatest common factor that they both share, 1A plus 3, And if we pull the 1a plus 3 out of this guy, we're left then with just this 1a. So 1a. And if I pull the a plus 3 out of this part, we're left with that positive 9. Now, again, I like to use brackets because as you get in the later years, you might have more stuff that you're factoring out, but you'll also see a lot of teachers will also just use parentheses. Both are very good. Okay. Now, that is one method to go about it. Okay. And it's pretty much like a fail-safe type of method. So that's why I more approach it in that way and stress that way. There is, however, another just equally awesome method. And the bonus here is that it's a little bit faster, but you kind of have to be very skilled with your number sense. So, and they can especially get harder. So this first one's not going to be too bad, but when you have other numbers at play, especially when A is a composite number, you might be doing a lot of guessing and checking. All right, so how you would factor this down using this other method is that guess and check. We're going to create 2 parentheses. And so what I'm going to ask myself is what times what gives me this 1a squared? Well, 1a times 1a gives me 1a squared. Now I'm looking at this number 27, and I'm asking myself, well, what times what can give me 27? Well, I could try 1 and 27, but when I do my outside and my inside, I'd have 27a and 1a. That's not going to give me my middle guy 12. So I might try and change up some of those numbers. And so I might go with then instead 3 and 9. Well, when I multiply those 2 values together, there's 9a, here's 3a. Oh, that can give me a positive 12a. And in order to do that, they would both have to be positive, so then they would both have to be positive. So it's a faster way, potentially, and usually it is, but you have to be pretty skilled with your number sense, especially when they get harder. All right. Now looking at number 10, but if you do it the way we've been doing it in class, it will always pan out, unless it's not evenly factorable. And we try and limit the number of those, so most of the time you can factor it. All right. Next, remember, rule number 1 is you always want to try and factor out a greatest common factor. Like you always start there. So is there a number we can evenly divide all of these by? Well, we can't use 2. 3 is not evenly divisible by 2. We can't use 3 because 3 is divisible by 2, but 16 is not evenly. So, and then we're past any kind of potential number because 3 is kind of the smallest one that we have. But you always generally try if you can do a GCF. So we can't. And as a result, we're going to identify our A, our B, and our C. And we circle them. Now comes our X method. So we have A times C on top. So we have 3 times negative 35, which that should give us negative 105. And our B value is 16, or negative 16. So now we're going to create a list for 105. Again, the sign, the negative 105, isn't as important. We just care more about the number. So we got 105. Well, 1 and 105, we have, it's not divisible by 2, 3 and 35. Not divisible by 4, 5 and 21. 6, I don't believe so. 7, no. Let's see, just to make sure. 7. Oh yeah, 7 does work. Okay, so 7 and 15. 8, no. Let's see, no, 9 won't work. 10, and then that's pretty much it. That would be our That'd be our list. So looking at our list, which pair combine in any possible way to this b value negative 16? Well, there's our winner. 5 and 21 can give us negative 16. So in order to get negative 16, 5 would have to be positive, and 21 would have to be negative to combine to give us that negative 16. And so as a result, we are going to be splitting that middle term. So we end up with positive 5x and negative 21x. Now recall, the other items, they just drop down. And then we break these guys down the middle and think about our greatest common factors. So as we look at 3x squared and 5x, we can pull an x out, 1x. And when we do that, we would have 3x plus 5. When we do our greatest common factor for negative 21x and negative 35, if he is negative, remember, we have to pull that negative out. And so their greatest common factor we can pull out is negative 7. If we divide both by negative 7, we'd have our 3x plus 5. They match. That's a beautiful sign. And so again, recall, it's pretty much just that item that matched, 3x plus 5, and then the leftover stuff in its own parentheses. So 1x minus 7. Okay. Ultimately, what you are doing is you're factoring this item, and that's what's going on behind the scenes. All right, so there is our factored form. Now, again, the fast way, or the kind of guess and check method, okay? I'm going to go ahead and rewrite it down here. So we have 3x squared minus 16x minus 35. This is where you go ahead and you create your two different parentheses. And what you're asking yourself is, what times what gives me this 3x squared? Well, 3x and 1x do that. Now, what are my factors of 35? Well, I could choose 1 and 35. I could choose, 5 and 7. I'm going to go ahead and just show you 5 and 7. Now, let's suppose for the moment that I'm going to say I think 7's here and I think 5 is here. Right now, I don't know if that's correct or not, but I'm going to just place them there. I'm going to guess there. And so when I try distributing that, I get 15x, and here I get 7x. Well, that is not in any way going to combine to give me my negative 16. Like, I tried it, it didn't pan out and work, right? Like, I get 22x or 8x, but not negative 16. So as a result, then I might just try flipping the 5 and the 7. So I'm going to put the 7 here and the 5 here. And then usually you pretty much just have to worry about the outside and the inside. So there's 21x. And then there's 5x. Oh, that can combine to give me negative 16x. Like, you're trying it out and seeing if it works. And you might guess correct, like strategically guess the right combination. Well, in order to get that negative 16, my 21 has to be negative. This has to be positive. And so playing with those signs to get that negative 21x, this value had to be negative. And to get that positive 5x, this had to be positive. So you're then using those signs to work slightly backwards. Okay. Again, that's the guess and check method. The downside with that is you might be guessing, several values from the list. So it does have a drawback. But the way that we've been doing with the splitting the middle term is pretty, you can very much rely on using it. All right, next up, 8x squared minus 22x minus 21. Is there a GCF? Remember, you always start. Is there a GCF? Well, 2, he's divisible by 2, so is he, but 21's not. So as a result, no. 3, no. 4, no. 5, no. Doesn't look like he has a GCF, but we try and make our lives a little easier. And unfortunately, it didn't have one this time. So we then move into, all right, let's identify A, B, and C. Here's A, here's B, here's C. We then go to our X. We have A times C, which is 8 times 21. Our B value here is negative 22. Now, 8 times 21 is 168. And so we have to create a list for 168. So we have 1, 168. And this is where calculators are definitely pretty handy. So we have 168 divided by 2 is 84. So 2 and 84. We have 3 and 56. We have 168 divided by 4 and 42. 5 no, 6, let's see. Yep, so 6 and 28. Now, if you identify something on your list that works, so I can spot right now 6 and 28, that can combine to give me negative 22. What we would do is then we would probably try that. A very comprehensive list, though, is going to cover you no matter what then. Most of the time, this is going to work, okay, when it's that one pair that gives you your B value. But we've seen in the past that there are definitely times where, there might be multiple items that can multiply to a value but combine to another value. So a very comprehensive list is always safe. But we'll say, okay, we got 6 and 28. Well, to get the negative 22, I need positive 6 and negative 28. So those are our values. Let's try out. So we have positive 6x and negative 28x by splitting that middle term. The other items just drop. So we have negative 21, 8x squared. And then we can go ahead and break this guy up down the middle. So as we do our greatest common factor of here, we have a 2x that we can pull out. And when we pull that out, we're left with 4x plus 3. Looking at our greatest common factor from the second half, well, we notice he's negative, so we got to pull the negative out. And they're both divisible by 7, so negative 7. And when we divide both items by negative 7, we're then left with positive 4x and then plus 3. So they match. That's great. They should. And then our final factoring answer would be 4x plus 3 times 2x minus 7. Now, this is the last kind of like guess and check method I'm going to show. But say that you wanted to use the guess and check method. You're like, I really see it. I think my number sense are really on point and really good. Here's how you would kind of try it with this. You have 8x, or I'm sorry, you create your 2 parentheses. There's no GCF. So we go ahead and create our 2 parentheses. Now, what times what gives us 8x squared? Well, 8x and 1x do that, right? This 21, what times what gives us 21? Well, 3 and 7 do that, right? So I'm going to try maybe 3 here and 7 here, and then let's see what happens. You always mainly hone in on the outer and the inner. So here we get 56x and 3x. Well, that's not really going to give me 22, right? So then I might try swapping my 7 and my 3. And with this number sense too, I just tried 7 and 8 a moment ago, right? Now this is at least going to give me a smaller value, which is closer to my negative 22. And so there's kind of that layer of strategy within that, okay? And that's what I mean by your number sense skills. 7 times 1 is 7. Well, 24 and 7, that's not going to combine to give us 22, unfortunately. Now here's the kind of downside drawback. Well, I could try 3 and 7 like I just did, or I could try 21 and 1. Spoiler, that's not going to work. Okay, even if I try 1 and 27. Now, alternatively, though, what makes that guess and check method a little bit tricky is what times what gives us that 8x squared? Well, 8x and 1x do that, but so do 2 and 4. And so now I'm not just having to play with the last number, I actually have to play with the first number. So like 4x and 2x give me this 8x squared. So now there's just more options when this guy right here is what we call composite. It's not as clean cut. You have to try more stuff. And so I'm going to go with 4x and 2x, and then I'm going to say I'm maybe 3's here, maybe 7's here. So 4x times 3 would give me 12x. 7 times 2 in the middle would be 14. I can get 26, but not 22. Well, let's try swapping then the 3 and the 7. So we'll put the 3 here and the 7 here. Now let's see if that works. So 4 times 7 is 21. That's not working. And then 3 times 2 is 6. I'm sorry, that was 28. 4 times 7 is 28. And then 3 times 2 is 6. Oh, yes, that can combine and give me 22 in the middle, right? But again, I'm trying to get negative 22, so this has to be negative. This would have to be positive. And then to get that negative 28x, the 7 would have to be negative, and this would have to be positive to get that positive 6x. So there's a lot more guessing going on. Now, again, though, if you work with your numbers frequently, especially multiplying values, you can become quicker at it to the point where you can start to see what there are certain likelihoods of occurring. Okay. Generally, too, guys, if you try and you're like, I'm adamant about the guess and check method, generally you're going to be finding yourself looking at values that are like 2 and 4, the more closer inner numbers, and 3 and 7, as opposed to something like 21 and 1 or 8 and 1. Generally, you're going to be looking at values that are those factors that are closer together. Okay. Now that's not like an ironclad guarantee, but it's a kind of just common practice that they're just happen to be closer. All right. Next up, we are factoring where A is a composite number again. We always try with our greatest common factor. And while it's tempting to try 9, this guy is not divisible by 9, and he's also not divisible by 3. So as a result, we don't have a GCF on this one. And so we're just going to have to pretty much use our X method. So we have our A, B, and C. So we have our X. A times C is 9 times 90, which is, let's say that's 810. Should be. Yep. So 810. And then our B value is negative 71. So now we have to create a list for 810. That is quite a list. So we have our list for 810. Numbers like 1 and 810 aren't going to be so used. So we're going to then look at like, okay, what are some maybe larger numbers and kind of skip some just to get values? Because like I could do 2 and then what, 405? That's not going to give me 71, right? So I might skip down a little bit to something like, oh, I don't know, I might try like 15. See if 15 works. 810 divided by 15. So 18 or 15 and 54. Oh wow, does that work? Swear to goodness, did not plan that at all. Yeah, that combines to 71. Okay. Well, we'll take that, I guess. They would both have to be negative. I kind of already see what's going to happen though. But they'd both have to be negative, correct? So we have negative 15 and negative 54 to give negative 71. Now, I go and split my middle term, right? So we have negative 15n and negative 54n. Other items just drop down. And then we're going to go ahead and split right down that middle. So now, looking at our greatest common factor from the first one, well, we can pull a 3n out of both of them. And when we do that, we're left with 3n minus 5. And this guy's negative, so I have to pull the negative out. So negative 54 and 90, they're both divisible by 9. And I feel like there's a value bigger than that. 18? 54 divisible by 18. Yeah, I think so. Yeah, 3. So negative 18, I can factor that out. 90 is divisible by 18, so this would be 3n and then minus 5. Okay, so they match. That's a good sign. And so you're factoring that 3n minus 5 out. And when we pull out that 3n minus 5 from both of these terms, I'd be left with just the 3n from here, and then my negative 18 from the second one. Is 71 divisible by 3? I think it was. Yeah, no. All right, so I did notice one of my factoring was slightly off. So like in terms of the signs, in this second one, you would pull out a negative 18 like we just did. But I realized that this would be positive. Originally, I didn't think that this was going to actually work. That's why earlier when we were doing the list, I was like, actually, this might not. But notice how they look super similar. Like one is 3n minus 5, and the other, because we pulled out negative 18, is actually 3n plus 5 there. Those are not then the same. So let's get rid of this. Let's get rid of that and that. The 3n minus 5 and then the 3n plus 5, those have to be identical. They have to match. And because of that sign, they're not. They're not actually matching there. So as a result, what that tells us then, I'm like, man, a lot of things are going right. And I didn't think that it would come out the way that it did. And that's why it's not. So as a result, this though is not then the right combination. So this is that question where, you might have multiple items on your list that combine to that negative, in this case, 71, like negative 15 and negative 54 do that. There's another item though on the list that can do that. So for example, 10 and 81. So 10 and 81. And if I made 81 negative and this positive, well, that multiplies to negative 810, but then also combines to our negative 71. So that's why having a very exhaustive list all the way is very helpful. Now, what'll happen is like a pair that I thought would work, like it does combine to B being negative 71. But then when you get to the actual factoring part, notice these not matching. That is kind of like your red flag of saying, hey, this is your incorrect pair. Okay. So negative 15n and negative 54n are not then the right ones. And so as a result, it's going to be our 10 and negative 81. Earlier, I was thinking, I don't think that that's actually what it's going to be. But then things started working out that it should. And I'm like, oh, okay, well, then I guess maybe it is panning out. But I messed up on one of the signs there. So I guess I got too excited and really thought it was going to be it. All right. So now we're splitting up our middle term, negative 71, into 10. So we have 10n, positive 10n, and negative 81n. That still combines to negative 71, but also multiplies to 810. Now we're going to go ahead and split that middle term. And let's see if this is now going to give us that matching one that we need. At this point, I really don't know if it's going to combine or not. So we can pull out a 1n, and 9n plus 10 is what we would be left with. As we look at the second one, we can factor out, again, a negative, and they're both evenly divisible by 9. So 9n plus 10. Got the sign correct that time. And here, yes, they in fact do now match. So that then is telling you, yes, I got this pair correct then, even though the other pair worked too. All right, so now we factor that guy out. We have 9n plus 10, and then the leftover 1n minus 9 in his own parenthesis. And there it is. That would be your factored form. So just be careful that, yes, a pair works. That might not be the only pair that works. And so having an exhausted list is pretty helpful. All right. Moving on to number 16. We always want to try with a GCF first. And I believe, yeah, we can do 3. Let's say if 168 is divisible by 3. It should be. It is. Awesome. Okay. So yeah, we can factor out a GCF of 3 from all of these terms. So we can pull out a 3 from all 3 terms. And when we do that, we're left with 4a squared plus, that would be 19a. And then this would be minus 56. Okay. So we pulled the GCF out. And now we're going to try and break down this trinomial here. So we're going to use our X method. We've got our A, our B, and our C. Here comes the X. Got A times C, which is 4 times negative 56. And so then that would be negative 224. Our B value is 19. And let's go ahead and create our list then. It's positive. So our list is negative 224. Again, really just focus on the number. We got 1, 224. 2, 112. 3, sure it is. It should be. Oh, no, it's not. 224 divided by 4, that should be. So yeah, 4 and 56. 5, no, 6, let's see. 224 by 6. It shouldn't. Yeah, because it's not moving by 3. 7. Yep, 7 works. And 32. And then 8. Yep, 28. 8, 28. Ooh, that's close. That would be 20. Not quite the 19. Let's try 224 by 9. I think so. Yeah. 224 divided by 10. No. 11. No. 12. 12. No. 13. Doubt it. No. 14. 14 and 16. And so we're kind of getting at our list where we're like, oh man, 15 would not work, and then pretty much you'd start having duplicates, so you don't have to duplicate. And it's looking like none of these are combining to give us 19. So that, yeah, that would be it. So that's as far as we can actually take it. I mean, we tried an exhaustive list. We did our GCF right away, right? And then we tried breaking down the 4a squared plus 19a minus 56. But unfortunately, when we created our list, there's no pairs that combine to give us that 19. So actually, that would be your final answer. It's the 3 times the 4a squared plus 19a minus 56. Go ahead, feel free to pause the video if you have any questions at all on that one. All right, now moving on to number 18. Again, we always kick things off with the greatest common factor if we can. And it looks like here we can. So we can pull out a 2. You would try 4, it does not work. 8 would not work. But 2, we can pull out a GCF of. So when we do that, we have 4v squared plus 33v, and then plus 54. Okay. Now going into our X method, we have our A times C. So 4 times 54 is 224. And our B value here is 33. And for our list of 224, oh, it is the same. It's the same one. Okay. Oh, wait, no, we have 54, not 56. Almost got lucky there. So 54 would be 216 then. So it would be 216. All right, so creating our list for 216, we've got 1 and 216, 2 and boom, there's our list. Figure that would just be easier for you guys. In looking at the list, we do have a pair that combines to give us 33, and it is the 9 and the 24. So we have 9 and 24. And to get that positive 33, then they both have to be positive. So now we're going to go ahead and split that middle term. And so we have 9v and 24v. And then the 54 drops, and our 4v squared drops. Now we go ahead and split the middle term. So we go down the middle, and then looking at our GCF here, we can pull out a v that they both share. So 1v, and then we would be left with 4v plus 9 as a result. Looking at the second pair, we can pull out a 6, and that seems to be the biggest. So positive 6. So 4v plus 9. We factor out a 6. And then we would end up with 4v plus 9 times the leftover 1v plus 6. Now, this is what happens very, very often. Students will be like, okay, great, I'm done, yay. Do not forget your greatest common factor that you did at the beginning. Okay, if you forget him, then it would be incorrect. So that GCF at the beginning, just don't forget him, and that would be our final answer. Okay. Now going ahead and looking at 20. Well, we know that we can do a GCF, definitely 5. Let's see if there's anything bigger. I think that might be the best that we can do. So All right, we got our GCF of 5 that we can pull out right away. And so then we're left with 4x squared. This is what, 23? Let's make sure. 1 by 5. Yeah, 23. XY. And then 360 divided by the 5 would be 72. Minus 72. Y squared. Okay. So now we're going to go ahead and try and break down this trinomial here. So we've got our x with our a times c. And so in this case, we got a is 4, b is this negative 23, and c is that negative 72. So we have 4 times, again, 72, negative 72, doesn't matter as much, but it'd be, we have 288. So 288. It's got to be negative 288 that it multiplies to, but then adds to negative 72. So let's go ahead then and create our list for 288. Again, we mainly just care about the number. Again, 1 and 288 is not really going to get close to 72, so we might skip a few. 288 divided by, let's see, 396 is on the list, but it doesn't really do anything. 288 divided by maybe 6. So 6 and 48, about 288 divided by 4. Let's see what that does. Okay, so 4 and 72, but that does not combine to give us 72. 288 divided by 288 by 6. I'll spare you guys. And I just realized that's not our b. Our b is the negative 23 that we're aiming for. All right, sorry about that b value. So there is a correct pair that does combine to give us our negative 23 that we need, and it is this 9 and 32 that can do that. So we're going to go ahead and break it up. We have our 9. We have 9 and negative 32. So we have our 9 xy and our negative 32 xy. The other items, they just drop down, so negative 72y squared and our 4x squared also. Now we're going to go ahead and split that middle term right down that middle, and then greatest common factor what we can. So we would pull out, looks like we can do an x, like a 1x, and be left with 4x, 4x plus 9y, plus 9y. And then looking at the second one, we can pull out a negative 4. Yeah, negative 4. Y. And if we do that, we're left with, or is there maybe one bigger? 16 might work too. Actually, we can pull out negative 8. Just realize we can do negative 8. Y. And then we're left with 4x plus 9y. And lo and behold, they do match. It's always a good sign. And so then we would have 5 times the 4x plus 9y, the matching one, and then the leftover as a result, the 1x minus 8y. And that would be our final answer on that one. Okay. Sorry, just really big values and a lot of variables going on. So, all right, next up, we have factoring the difference of 2 perfect squares as well as a binomial being squared. Now, as we look at number 2, we recognize this as the difference of 2 perfect squares. And anytime it's in that form like that, and you'll see it all throughout mathematics, they'll be kind of just randomly thrown in at times. That is the form a plus b times a minus b. And so as a result, when we break this down, we've got our two parentheses. What times what gives us this 25n squared? Well, it's 5n and 5n. What times what gives this 4? 2 and 2. And then one of them's plus and one of them's minus. So that's what we mean by a plus b times a minus b. And so that would be our factored form. You could use the whole x method and split the middle term. B was 0 in that case, but this is just way faster. For number 24, again, we're recognizing the difference of two perfect squares. So we create our two parentheses. And then it takes that form, a plus b times a minus b. 2x times 2x gives us that 4x squared. The 4y and the 4y give us that 16y squared. One of them's plus and one of them's minus. And you could distribute if you really want to like verify it, but that would be the same value in the end. Okay. And just looking at this too, you could also GCF things right away. And that would be even like a better answer. So like, for example, we could factor out a 4 immediately. And when you do that, you'd have x squared minus 4y squared. And this is still the difference of two perfect squares. So we would have your two parentheses. What times what gives us this 1x squared? 1x and 1x do that. And then what times what gives us this 4y squared? Well, 2y and 2y do that. And then one of them's plus and one of them's minus. This is actually like the better answer of the two. What would happen with the previous is like you'd factor out a 2 here. And then you'd have like a 2 times a 2. So the red is really the better of the two answers, guys. All right. But the black one is not too bad. All right. Next up, we have 5 that we can GCF right away. So we can pull a 5 out, and we're left with a squared minus 10ab, and then plus 25b squared. And this is that binomial being squared definition that we've seen. Now, how this would look is, you could factor out your GCF, which we just did, and then we go into our x method. So we've got our 1 is a, better, negative 10, and then c is that 25. So we have a times c, which is 1 times 25, or 25. Our b value here is negative 10. And then what times what gives us that 25? So our list, 25. Well, 1 and 25 do that. 5 and 5 do that. And that's really it. And yeah, 5 and 5 are going to give us that negative 10 that we need, but both of them then would have to be negative. So as we go to split the middle term, let's give ourselves some space. There we go. We could split this up into negative 5ab and negative 5ab. The 1a squared drops, the positive 25b squared drops, and the 5 in front, representing our GCF, also drops. Okay. Now we go ahead and split that middle term. So looking at this first guy, we can pull out a 1a that they both share. So 1a. And if we pull a 1a out of him, we're left then with 1a minus 5b. Looking at the second pair, we can pull a negative 5b out of him. So negative 5b. And when we do that, we're left then with 1a minus 5b. Finally, we kind of pull that GCF out, the 1a minus 5b, because they match. And they should, they do. So we've got our 5 on the outside, our 1a minus 5b part, and then the leftover part, the 1a minus 5b, coming from him and him. Now, here they end up matching like identically, and that's because really this is a binomial that is squared. Like these two are the exact same thing that are getting multiplied together. Imagine for a moment, it'd be like if you had 7 times 7, all that is the same as 7 squared, right? That's what's going on with this guy. We got our 1a minus 5b. Oops, supposed to have a b. And then squared. And then we just have our 5 right out in front. Okay. Go ahead, feel free to pause the video if you have any questions. All right, next up, we are going to go on to factoring and solving. Now, when a is 1 like this, you can use the whole x method. It's a fantastic method to use. I'm going to go ahead and do like that, not guess and check method, but you might be able to recognize, oh yeah, that might be a little bit faster on this one. So 1x, especially when it's 1x and 1x give us 1x squared. And then what are the factors that multiply to 14 that add to 9? Well, that's 7 and 2 do that. Everything's positive in here, so everything has to be positive. And there's our factored form. Again, you can use the x method that you've been studying for most of the factoring. But in the end, you should get 1x plus 2 and 1x plus 7. Now, because we're factoring and we're solving, notice how it is equal to 0. That must happen. So this is where we split and solve. So we're going to say 1x plus 2 is equal to 0. And then our 1x plus 7 is equal to 0. This is coming from 6.4, specifically that section. So if you have questions, go check out more of those examples. Now we go ahead and solve each one. Minus 2 minus 2. We get 1x equals negative 2. Divide. We see x is negative 2. That is one answer. And then for this guy, we subtract 7. We get 1x equals negative 7. Divide, divide. X is negative 7. So it is those two solutions. For number 30. We have to try and factor or solve by factoring. And in order to do that, we need to get everything over to one side of the equation and 0 on the other. Generally, too, you want your a value, like the highest degree leading coefficient, to be positive. So noticing our degree is 2 here, we're going to want this guy to be a positive number. All right. So to ensure that he's positive, we're going to go ahead and subtract the 2a squared from both sides. Boom, boom. He's gone. Equals 0 on the right side. That's good. That's what we need. And then the 7a squared minus 2a squared gives us a total of 5a squareds. The other items, they just simply drop down because nothing was combined with them. Okay. Now we ask ourselves, can we GCF anything? Unfortunately, we can't. So then we move on to factoring. And so then this is where our x method comes in. We have a times c, or 5 times 56, which is it's like 230 times 280. 280. Oh yeah. B is negative 47. And so now we're going to go ahead and create our list for 280. All right, there's a pretty solid list. And lo and behold, we see 7 and 40. Well, that can combine to give us negative 47 as long as both of them are negative. And so then we go ahead and we split up our middle term with negative 7a and negative 40a. The other items just drop down. 5a squared plus 56 equals 0. And then we break up down the middle. So this is really nothing new. GCF, we can pull a 1a out of that first pair. And so then we're left with 5a minus 7. Looking at this, he's negative, so we have to pull a negative out. And then they're both evenly divisible by 8, so we can pull an 8 out as well. And so then we're left with 5a. And if we divide positive 56 by negative 8, we're left then with negative 7 equals 0. These two match. That's a fantastic sign. So we pull that out. We have 5a minus 7. And then the leftover 1a minus 8 equals 0. And at this point, we are good to split and solve. So 5a minus 7 equals 0. And the 1a minus 8 equals 0. Again, remember, this is zero product property happening. If this was suddenly 0, well, 0 times any number is 0, isn't it? So that's why we can split them up like this, and vice versa. If this guy is one big 0 times any number, well, then that left side is going to be 0, which is definitely equal to 0. And so that is our zero product property. That's why we can split and solve, set each one equal to 0, and then solve for each one. So add 7. Just kind of a quick recap of 6-4. And usually these guys are solving two-step equations. So add or subtract an item over, divide. And this guy, we just add 8, 1a equals 8, divide. A is 8. So we got 7 over 5 and 8. Go ahead, feel free to pause the video if you have any questions, but it really boils down to getting it equal to 0 on one side, GCF if you can, factor using the X method, and then split and solve. All right, moving on. We're now going to go ahead and use the square root method. Okay, so this is coming from 6.5. So this is our 6.5 notes. All right. Now, how we do that is we're trying to solve for our variable. And so we're going to try and get rid of all those other items around that variable. And how we do that is it's a lot like solving a moment ago, how you added and subtracted an item over and then divided an item over. It's a lot like that. So we're going to add this 9 over to both sides, because our goal is to isolate our a and get it alone. So we have 2a squared equals 50. And next, we go ahead and divide this coefficient of 2. So a squared is equal to 25. And now we have to take the square root of both sides, because we don't want a squared, we want just a. And that square root cancels with our exponent of 2, leaving us just the a. And remember, in math, the moment you do a square root on both sides is the moment you have your plus minus answers. And so as a result, the square root of 25 is 5. So a is positive 5 and a is negative 5. Both of those answers. Okay. All right, really fast. This is just a side one because we had seen ones like this in class. Say that this was your quadratic function, right? And we actually saw this earlier when we graphed the parabola. And a teacher is like, hey, we want those x-intercepts. Well, that's when we set our y value equal to 0. And we're trying to then find out where is it crossing that x-axis. Well, now we go ahead and solve. And we had seen this form in our notes. So here we would subtract that 2 over, because our goal is to try and isolate x. That positive 2 really has nothing to do with it. So we just subtract it over. We get negative 2 equals negative 2, parentheses, x plus 4, quantity squared. And now, again, our goal is really just to get rid of all the numbers around that x. So this negative 2 we're going to go ahead and divide both sides by that -2 in front. And when we do that, we just have our x plus 4 quantity squared equals -2 divided by -2 would just be regular +1. And now recall this at this point, this is where we actually take our square root. We don't try and like distribute the two. Remember, that's like the massive mistake in math. Here at this point, we're trying to get this x all by itself. So this is where we square root both sides. And when we do that here, it ends up canceling, leaving us the x plus 4 equals the square root of 1 is 1. But recall, the moment in math you do a square root on both sides is that moment you have your plus minus. So those are our two almost solutions. And then this is where we can split and solve. So we got x plus 4 equals +1 and x plus 4 equals the -1. And then we solve for each one. So we would subtract 4 from both sides. So it looks like x is going to come out to be 1 minus 4 is -3. There's one solution. And then when we subtract 4, x comes out to be -5. Okay. And so those would be our two solutions when we have like maybe a binomial that's squared like that. And we've definitely seen those in class and in our notes. But go ahead. Notice we got -3 and -5, right? Those represent right here, those x-intercepts that we found earlier on our graph. Okay. So that's like the algebraic proof of that. All right. Go ahead, feel free to pause the video though if you have any questions on solving using the square root from our 6.5. All right, next up, we are on our 6.6, solving with the quadratic formula. Now, in order to ever use the quadratic formula, it has to be equal to 0 on one side. Okay, and so to do that, what we need to do first, looking at 34, is we're going to have to add this 6 over to both sides. So here it cancels, and we're left then with the 4x squared plus 5x. Looks like minus 26 equals 0. Okay. So now that it is equal to 0, this is where, again, yes, we rewrite the quadratic formula every single time. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then we want to identify what is a, what is b, and what is c. So our a value is 4, b is +5, and c is -26. And then we dump those items in. And so we end up then with x equals the opposite of, anytime you dump the numbers in, we throw parentheses. So -5 plus or minus our square root. Our b again is 5 squared minus 4 times a is 4 times c is -26 all over 2 times our a value 4. Now we go ahead and clean this guy up a little bit. So we have x equals -5 plus or minus the square root of 5 squared is 25. And then here we're getting some very, very large numbers, right? We have -4 times 4 times -26. So that would be 416. So plus 416. And the reason why it's positive is because we have this negative times this negative. So negative times negative is that positive. And then this is all over 8 on the bottom. And now we've got x equals -5 plus or minus Square root of, bringing these numbers together inside the square root, we have 441 all over 8. And recall, this is where you want to try and use good and garbage. We need to try and clean up our square roots. And fortunately for us, that 441 is a perfect square, and it comes out to be 21. So we have x equals -5 plus minus 21 all over 8. And then this is ultimately then where we kind of like separate each one. So we've got x equals -5 plus 21 over 8. And then x equals -5 minus 21 over 8. And then we kind of clean up each version of it. So looks like x equals -5 plus 21 would be 16 over 8. And then 16 over 8 is just 2. So there's one answer. And then for the other guy, we have x equals -5 minus 21 would be -26 over 8, which would then clean up to be, we could divide top and bottom both by 2. So x equals -13 over 4, the other guy. Okay, so there's our quadratic formula. In prime action, keep in mind, you got to set it equal to 0 at the start. You then dump in your values appropriately and correctly with parentheses. We clean it up, and then we kind of separate each one and then simplify. So separate and simplify. Go ahead, feel free to pause the video if you have any questions on 34 though. All right, now looking at number 36. Recall, we need to make all the terms on one side and then 0 on the other side. Now, it doesn't matter which side, but you really want your a value. In this case, notice that x squared a is positive right now, and you generally want that to happen, okay? So as a result, knowing that, we're going to keep that 12x squared on the left side. We're not going to move him at all. And instead, we're going to subtract the 4x over and add the 10 over. And so when we do that, we have 12x squared minus 4x plus 10. And then these items canceled, so it's equal to 0 on that right side. We just added or subtracted items over to make it equal to 0. Now, can we factor something out? And the answer is actually yes. You do want to try a GCF here. And so we can pull out, in this case, a 2. So we can factor out a 2. And so when we do that, we have 6x squared minus 2x plus 5 equals 0. Now in class, we talked about, well, what happens when you have a number just like 2 on the outside there, and you're trying to solve? Well, that GCF, what we can do is just divide both sides by the 2, and then be left with the 6x squared minus 2x plus 5. And then 0 divided by any number is still just 0. But what we've done is we've at least brought down our numbers from all these, like, 12 and 10 and all that. We brought them down to smaller numbers. So it made our life a little bit easier, especially when you start using the quadratic formula. And you're squaring things, and you've got -4 times a times c, which can be big items. So we tried the GCF, it worked. Our life is now a little bit easier. Now identifying what is a, b, and c. Well, our a is 6, b is -2, and c is +5. And again, our quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We now go ahead and dump those values in. So we have x equals negative. B happens to be a negative here. So notice that there are own negatives. This guy's from the formula. B just happens to be a negative number. 2 separate negatives though. And then plus minus square root b squared. So -2 squared Always throw it in parentheses, guys, because if you try it in the calculator without them, it'll be a different value then. Minus 4 times A is 6 and C is 5. All over 2 times our A value 6. Okay. So we've plugged in our values appropriately. Now, let's go ahead and clean it up a little bit. So we have x equals the opposite of -2 is really +2. Plus or minus -2 squared. Be careful when you try and enter things in the calculator. It's negative in parentheses. So that'd be 4. -2 times -2 is 4. And then we have -4 times 6 times 5. Well, that's going to come out to be -120. All over 2 times 6 on the bottom is 12. Next up, we can go ahead and combine these guys together inside the square root. So we end up with x equals 2 plus minus square root of -116 all over 12. And now we're going to try and use our good and garbage. So we have x equals 2 plus or minus. We're breaking this guy up into our good and our garbage square root. And so using your VIP list, 4 is actually the best one that you can use. And you'd be left with -29 in the garbage. And then this is all over 12. And then as a result, we end up then with x equals 2 plus or minus 2 root -29 all over 12. And then we can divide all those little outside numbers by 2. And when we do that, we have x equals 2 divided by 2 would just be 1 plus minus 1 root -29 all over 6. And for a lot of people, they might be tempted to be like, hey, I'm done. Yay. Final answer. But remember, the moment that you see a negative in a square root like that is the moment your brain should pretty much just default to, oh, there's imaginary stuff. Again, it's got to be a square root. So, and then you've got an imaginary. So that's where finally we pull out, what is it? An I. Pull out that imaginary number. And then that number inside the square root becomes 29, positive 29, all over 6. So that would be your final answer. Now, like on a multiple choice test, it would be pretty much shown as like 1 plus or minus I root 29 all over 6. So you would see it like that. We've also talked about in class where it would maybe be separated. So 1/6 plus or minus I root 26, or I'm sorry, 29 all over 6. So you can see it that way too, where they pretty much just split each item up. Okay. But yeah, there it is. There's your final answer, or whichever one you prefer. So yeah, there, guys, is our study guide for our unit 6. Again, it's covering 6.1 through 6.6. Feel free to ask any questions that you guys might have all throughout, okay? For the other, just as a heads up, for the other two, the odds, 33 comes out clean, and then 35, though, I think you're gonna have, you're not gonna have imaginaries, but you're gonna have good and garbage going on. So that's just kind of a preview. All right.